Okay, so make sure you will be download the new information. That's what we need to talking about. Okay, so you see the schematic, right?
Yes.
Okay, now first thing is you have to, at least in general, then you have to know how the memory working. Okay, I just quickly go through it. Basically, you understand the U1, just a buffer. Okay, so the data go into port A. From port A go to U1, no problem. But you have to get the last U2. So the data from input here go to the inside U2, not out yet, until you need your pin 1 to be 0. That's what we're talking about, enable U2. So when they're going up here, you can going back to read to verify. That means the first two tests, you testing for data 55 and you testing for data AA. That will be test for U1, U2, U3, and also U4. Okay, in here. Now, the next thing is we can see you want to test U8 memory. So you can get the process is write data into the memory. And later on, you can read that data and verify correct or not. Okay? In order to do write data to memory, first thing you have to write the address. So address will be coming from right to port A, go into here. And also you have to get you to LAB and you to enable. So they ready in here. So if they go into the output of U5, that address, then you need to apply the clock for U5. That is how to get the address for memory. If you get any question, let me know. That is the process. Okay, after you get the address, now what you need to do is get the data right here. Okay, the data will be the same thing. You have to write the data from port A. And doing the same thing, U2 last, U2 enable. So the data will be right here. So now, that data you want to go to the U6. So that's why you have to get U6 last. Data will be go inside. And now, U6 enable. Data will be ready here. Okay? Then you can see data will be ready at U9. B1 to B8. Okay? And also they already get a direction here, dir direction. If a logic 0, then data will be go from B to A. Okay, and now the data already here. So that is how to write data to the memory.
And when you
So now you already get the address ready here, data ready here. Okay, and what you need to do is write data to the memory. For data can get into the location inside memory, you need pin 21, U8 have to be 0. Pin number 20 must be 1. The thing like that will be output, not in. So they must be 1. And enable, they have to be 1. They go to 0, then they have to go to 1. Then data will be already inside the memory.
Hey, Mr. Pham, I know you, if you could just go over that part just one more time regarding pins 18, 20, and 21.
Just a minute. Okay, now go ahead and what's your question?
U8 pins 18, 20, and 21, if you could just cover those real quick one more time.
Okay, you want to write data to the memory. Pin 21 must be 0. Pin 20 have to be 1. And pin number 18, they will be high, then low, then high, negative positive. So the data will be ready inside that location. That's for right.
Okay.
For the write process, you can see they can go from U1, U2, U6, go to U9, and go to the data of the memory here.
Mm-hmm.
You get that?
Got you.
Okay, now, next one will be read data. Okay. In order to reading the data from the memory, okay, first thing what you need to do, you have to get the address first. What location you want to read, okay? Then now, you already set the location. Then on U8, pin 21 must be 1 to read. Pin 20 have to be 0, so the data can going out. And pin 18 must be 0. That is how the data can be coming out from memory from whatever address you already set here. Okay, so when they going out, then that also will be set already in the hardware design at the logic 1. PIR direction. Logic 1 data now go from A to B. And they will be going down here. And they will be go down to U7. Okay? And U7 enable data will be go to port C. That's how you reading data from memory. So in order to reading data from memory, first thing you have to tell which address. Okay? Then you can get this, set it up to read. Again, pin 21 must be 1, 20 must be 0, 18 must be 0. Then the data coming out. And
Those are just the opposite of writing, correct, Mr. Pham?
exactly.
And one last thing, on the for writing, you have a pulse, whereas on reading, you do not have a pulse. Is that correct?
Exactly. Why we want that to happen? The thing is, when you're writing the data into the memory, you have to write address. You have to write a data. During the time you're writing address or you're writing the data here, you don't want anything coming inside. Okay? The thing is they screw up inside the memory. So that's why enable must be 1 during you try to write data to the memory. After you get address or you get the data ready, you put it low. Then data will be go into this address. Then you have to bring it up 1. Make sure any changing outside here didn't not screw up inside the memory. However, when you read memory, you have to tell what's address. Okay? And also you have to say pin 21 must be 1. That means the data going out only, not going in. So that's why they not screw up. Then enable, don't have to be using any port. Set it to be 0 to enable on the time. If you read, the thing is why data cannot go in, data just coming out. There's a difference between write and read. So basically that's just a very simple program. However, that requires little more. Okay, now.
Mr. Pham, just one thing, the ADC part of it, with the circuit that we got here, can you go over that just a teeny bit?
Can you say again what?
Okay, you got an ADC part of it where you where you got the array.
I'm talking about ADC now.
Okay, well then that array, then the array.
Yeah, we still get the array, right?
Right. In this lab, you have the array.
Right. That means on this one, I want you to testing for data loading using array and verify. Okay.
Okay.
The thing is, next will be a D or a circuitry. We add them up into the memory. So they're telling me either the lab 9 or the lab 10, the lab 11. You must understand. So later on, you will be deal with the DA circuit.
Yeah, I understand that. But what I was asking was, how does the array fit into this circuit right here?
No, the array, that means you can loading 43 input data into the memory.
Mm-hmm.
Then you can reading one at a time to make sure the memory working.
Okay.
And later on, an array will be loading your data into the memory, and the data from the memory will be using to test for DLAB circuit.
Am I correct that in this circuit, the ADC data function works essentially the same as it did for us in DLAB 9?
Yeah, the same thing DLAB 9 or this DLAB.
Right. Okay. Thank you.
But the thing is, I can retain few things, okay? But it's not a big deal. So any question, we're not using U10C, okay? That's why in the information, I already telling you we delete U10C.
I was going to ask about that tonight too.
Okay,
We're not,
so it's only U10A and B then?
right,
It goes to port D pin 6, but that doesn't make any sense.
right.
Mr.
And
Fan,
until today, I get the time to do for you guys, try to get you able to understand. Now,
Mr. Fan,
it is a thing.
Mr. Pham, somebody's calling you.
just a question.
Yeah,
On U10, that pin you're not using, how much current is capable of being pulled through that pin? The max, do you think? Do you know the answer to that?
you mean the current for what?
The U10 you said was not being used. How much current is waiting to be used at that pin?
No, yeah.
No, I'm just wondering what's available to do work.
That you can see, right?
I'll just go. I can look it up. I was just curious what the current waiting would be just for work.
No,
Excuse me for interrupting.
yeah, that doesn't matter. Not affect anything. We're not using it. We just remove it. Okay. This time, I've given you more things. You're supposed to know how to do it. First thing you see port B. Pin 8, pin 7, not connect. Pin 6 for memory Z, negative. That's active low. Pin 5 for memory right, active low. Okay? And pin B and pin A for U4. Okay? If you want to enable, in the past I using output enable. However, I'm lazy, so I just using enable. Then you have to get data to port B will be 0, 0, 0. If you question, have to stop me, okay?
Can I point something out real quick, Mr. Pham?
Yeah,
For this DLAB, port D, if you can go back to that you just had it on.
okay. Now, right now I'm talking about U2 enable,
Okay, I'll wait till you get there.
okay? So the thing is some students don't understand, okay? Why we drive to port B, 0, 0, 0. Okay, so you understand if we get a U4A decoder, if you get a pin 2, pin 3, 0, 0, then the pin 4 will be 0. 0, 1, the next 0. 1, 0, the next 0. That means output only 1, 0 at a time. So if you want U2 pin 1 to be 0, then you have to write to port B 0, 0, then pin 4 will be 0. So that's why I say you need to write to port B0 H00. Okay? And U6 enable. Now, U6 enable. U6 enable, that means U4A pin 5 have to low. So that means you have to apply this one here will be 0, 1. Right to port B 0, 1. Now, however, what U6 using for on this circuitry? What U6 using for?
When you write the data to the memory chip,
That means you want to send data to the memory. That means during the process, write to memory, right? That's for U6. So you want to write to the memory. So that's why in here, I say memory Z, I have to be a 1. And memory write, they supposed to be 0. So U6 enable, basically 0, 1. However, on the same port B, you have to tell which one on pin number 6, which one on pin number 5. So that's why U6 enable, you need to write 0H to 1. Not only 0, 1. The thing is, they also inside the port B. And then U7 enable. What U7 for?
reading,
Reading the data from memory.
Reading. That means data coming out go this way. So for U7 enable, you're looking here. Okay, pin 6 U4A, pin 6 must be low. However, at that time, then you want to read. So U8 pin 21 have to be 1. Pin 20, they must be 0. So that's why when I say U7 enable, I want memory Z must be 0. Memory write must be 1. Okay, so that's why will be 1. 2. 2 means enable U7. That is the thing. You have to write correct data.
Mr. Pham, I had a question on,
Yeah,
if you could go back to the schematic. And if you could just briefly go over U4B pin 15 and because U4A pin 1 is ground. So it's ground is ground. But pin 15, that's how you generate your pulse or whatever.
pin 15, U4,
Yeah,
connect to port B,
port D.
port D. Why we want to connect to port D? The thing is the output here they will be create the port output at U10.
Okay.
If you route it, then you cannot get any ports coming out here. So that's why every time you want large, then you have to apply PD pin 1, 1, then 0, then 1.
Because when you have a latch, you want to have the door closed, then open the door, let the data in, and then close the door again.
Right.
Okay. But what I'm trying to, okay, so that pulse from that comes from that pin 15, okay, like on U10A and U10B, U10A1 and U10B pin 3, the pulses go there and they go what, negative, and they come through positive?
Okay, first thing, you select this guy,
Right.
but they not low, they will be high right now.
Right.
Why? The thing is PD pin 1, high. So no matter what you select here, they must be 1.
Okay.
The thing is they disable.
Okay.
When you disable on, the output have to be high. So they will be high here, and output they will be low.
Mhm.
They're not large yet. Okay? So when you apply pin 15, 0, so this pin 12 here go low.
Mhm.
Output will be going high. Okay?
Okay.
Then you apply pin 15 now high. Then now this output here will be going low. You want to create the one positive pulse. That means when they go high, they lock it. After that, we want to lock it. No more.
So that type of thing takes place for both U4, 10, and 11 and 12, because that one of them goes to A and the other one goes to B.
Right. If you want to lock, they must be positive pulse.
Okay, all right.
Okay. So now in here, for any lot, then you need to write to port B. After you write port B, and you have to write to port D 3 times. 1, 0, 1. So now you understand how they latch.
And
Okay.
Mr. Feng,
Yeah,
that's the difference between the 373 being a latch, which is controlled by that pulse, and the 374, which is controlled by a clock transition, right?
right.
So you got your flip-flop versus a
374 D flip-flop.
flip-flop, not a latch.
X trigger.
Right.
D 373 D latch. They control by high at the latch, not the clock.
Right.
Are they
Okay?
both considered flip-flops, or only one of them considered a flip-flop?
Both of them, same thing.
Okay.
Only one controlled by the logical, one
Okay.
controlled by the clock.
Okay.
Now, how to write to the memory? First thing, if you want to write to the memory, then the first thing you have to write address. You have to tell which address you want to write data into it. Okay? You write memory address using port A. Write to port A, whatever, 08, 55, AA, or 01, whatever. Then you have to call the function U to that. Then you call the function U2 enable. And then the last one, you call the function U5 clock.
Mr. Pham, in this DLAB, we weren't given the function U5 clock, so you would just use a P clock and that would work, correct?
Exactly.
Okay.
Instead, you say P clock, but that didn't make sense when I read it. Okay? The thing I looked, if you typing in here P clock, that's working. However, at that time, I have to go back to schematic. I try to see where P clock.
Right.
However, if I using U5 clock, even inside, they get only P clock. But I understand we are going to apply the clock to the U5.
Okay, Mr. Pham, based on what Adam just said, so should we use the P clock or the U5 clock?
You can using P clock, they still working.
But if you use U5 clock, you have to create a definition and a declaration.
Okay, so Adam, you're saying just use P clock.
The thing is, when I said, if you call function UP clock, I can understand right away. You want the clock applied to U5.
So you would create a definition for U5 clock that was just P clock.
Oh, I see what you're saying. Your function definition would be void U5 clock, and then inside the braces, you would put a P clock.
Yes, sir.
Okay, thank you.
Then, let's see, how to write memory data. That is a for memory address. Now, memory data. First thing, you can write data to port A. Then same thing, you have to using call U2 U2 enable. Okay, and now they already, you have to call function U6 lat. And finally, U6 enable. Okay, so basically up to this point, data already output from U6 to the memory data. Then you have to apply pin 6 on port B, logic 1. Pin number 5, write to memory 0. That's what you have to write to port B. Then you have to do a apply to port D 3 times. Okay, that means you get a memory enable 1, 0, and 1. You have to write 0i02, 000i02. So the data will be already inside the memory. Now, how to read data from memory? In order to read the data from memory, you have to make sure you can get the address. Okay, which address you want to read. That means you have to apply the address. Okay, after you apply the address, okay, and now you want to read, then pin number 6 on port B, memory Z must be 0. Pin 5 must be 1 for read. Okay, and enable on port D, they will be 0, not negative
Quick
Oh.
question, Mr. Pham.
Yeah,
Would it matter if at this point you wrote to port D0x01? Would that affect the outcome?
you
Since-
mean to port D,
Correct.
0801.
We don't care what's at pin 1, correct?
Exactly.
Okay, so it could be 1 or 0.
Doesn't matter.
Okay, thank you, sir.
Okay. And after you read the memory, the data will be enabled. U7. When you say you read memory, then what will happen is data will be coming out here. And direction already set to a 1. Data go to U9 and going down here. Only thing you need to make sure enable U7, data can go into port C. You see that's how easy, right? Now,
Too easy.
I go to the okay, I go into the program. This is the program. I try to correct few things here. Okay, the thing is you guys already correct me. Okay, I want to correct, let's see. Last time you told me correct for U2 lat, right?
Yeah, that looks like you have it correct now. U2 latch should be 0x00 and U6 latch should be 0x04.
Okay. Let's see, I'm looking for U2 lat first. U2 lat. So basically you write to port B00, right?
Yes.
Okay.
And that essentially eliminates the need for a U2 output enable because you're setting the conditions there for U2 to be output enabled.
Okay, that means the same thing. Okay, what else we correct that? U6 lat. U6 lat, the data will be 0x04.
Yes, sir.
That's only two things, right?
Yes.
Okay, I make sure I build it to make sure what they record, whatever we change it. So basically, if you're looking into my program, I just copy from the information into here, right? So you get the U6 lat, then you just copy from whatever, okay? In the information, you can get the U6 lat definition.
Mr. Pham,
Now, I want to talking about write address to memory. You want write address to memory. You say write to port A, ADD. ADD here, that means if you want to write address AA, then you can put the write address to memory 08AA. Then that will be going to here. Write to port A 08AA. Then you need you to latch. Then you need you to enable. Then finally, you get U5 clock. So that completely writing address to the memory.
And when you say U2 enable, you mean U2 output enable?
Right. I said
Okay.
lazy, so I take out the output.
Say that again.
I am lazy, so I take it out the output enable.
Oh, you just put U2 enable.
Make it short.
And we, at this point, Mr. Pham, we still have U8 on standby mode, correct?
Nothing to do with the way.
Once the data is clocked through U5, that data will stay there and you can write new data to port A and it will not affect the
U5.
data.
The thing
Okay,
is you're not clocked, so input cannot go into.
exactly. Okay, thank you.
If there any one question, then you have to bring it up. You
Mr.
want to
Pham,
be, you want
Mr.
to be a real technician. That it requires your knowledge.
Mr. Pham,
Yeah, go ahead.
okay, can you go back to the schematic? I mean, I'm questioning this part where we go U2 large and then U2 enable, okay? So therefore, when we first do the U2, okay, and we want to do enable the large first without enabling the output, okay, then you would then need the pin 11 to be high, but then the output you don't want to enable until you do the enable output.
That doesn't matter.
Okay.
But the thing is, you can set the pin 1 U2 to be 0 while you lock.
Mm-hmm.
They automatically coming up.
Right. That I know that's fine, but then when you set that, because when you write to port B, it also control the U6 at the same time, and you don't want U6 to go through when you write the address.
Right. The
So
thing is
therefore-
what we want. I want to separate it.
Mhm.
I want you lock first. Then I want you enable later.
Right.
Okay? You can enable at the time you lock. That be fine. However, you understand me, when you apply into last, data here will be go inside,
Right.
not come out yet
Yes.
until you enable pin
Right.
10.
So
And that
so
depends on the
therefore,
circuitry.
So therefore, when you write port B, if you were to write 0x03, that would just enable the large and not the output. Is that correct?
Output pin 1 must be 0. That means here.
But then if I don't want to output, I only want to large it, then that has to be
Now
1.
last is here. Not here. You see last degree in here.
Right. I want it large, but then I don't want the output.
Yeah, that doesn't matter. You don't care. Why you lasting? You don't care what here.
For this circuitry, it doesn't matter, but it's a choice that you have depending on the circuitry.
Right.
Yeah.
But then if it's pin U6, it does matter then.
If that means you already normally you already get this to be low. If it cannot be low. Okay, that not affect anything you see until you select pin number 5 low. That means this have to be 01.
And again, the pins on U4 that control both U2 and U6 both run through
Yeah.
inverters.
They control U2, U6, U7.
So when you have the pin, when you have, I'm sorry, when you have U4 pin 11, when that comes low,
That's a different.
when that comes high, it comes out low for U6 pin 11. They run through inverters, so you get the
Yeah.
opposite effect at
That's
the
a logic.
right,
That not affect anything here.
right.
Hey, Mr. Pham, hold up, don't go nowhere. Where you got U4B, pin 10, you got that going to U10.5, but you said you take that out of the circuit.
Yeah. We're
Pretend
not
that's not
using.
there.
So then pin 10, that's not connected then, right?
Right.
Okay, so U4B, pin 9 and 10 are not connected.
Correct.
Okay, thank you.
When I upload for the assignment, schematic will be corrected.
Oh, you're gonna make an update, right?
Yeah. When I make assignment,
Okay.
right now we on the handout.
Just a handout side thing.
Yeah.
But I just wanted to make sure that,
Yeah, they will be updated.
okay.
Okay.
I was gonna get my stuff from Kumi.
So that is how to write address to memory. That's what you need to do. Okay, any question? How to write memory?
And on the write the data, so that's almost like write address to memory, write data. So you write integer data, and then you write the port A det.
Now, write data to memory. What your
Yeah.
definition? First thing, you have to write to port A. Whatever data you want, you put up here. Okay? You said write data to the memory 08055. So 55 will be go down here. Okay?
Mhm.
And you have to do the same process to latch, to enable.
Okay.
Now you have to get U6 latch. So data will be get out to the output of U6. Okay? And U6 enable. That's how you write data to the memory.
And again, when you write U2 latch, it doesn't affect U6
No, never.
exactly.
The thing is that decoder, only one low. The rest must be high.
Right.
This is the thing you have to put it into your write data to memory definition. So the thing we're using the definition, the function, that easy to helping you to understand the process, how the signal transmitted inside the circuitry.
So it's always write address to memory, write data to memory, and then write to memory is the last one.
If you want to test in memory.
And U6 output enable, that function also controls U9's direction for writing to data.
Exactly.
Right.
The way the hardware design. So you don't have to.
We don't need a separate function for that.
Right. You don't have to worry about direction for you now.
And we don't need a pulse when we do the write to memory.
Right now, I'm talking about write data. That means make sure data already at the memory. We're not talking about write yet. Right now, you get already a thread, right? And you already get the data here. But nothing goes inside that until you get this thing set it up.
Yeah.
That's what we call write memory. You see, write to memory. Write to memory, you need to write to port B. Okay? To 0. Then you have to apply the negative post 1, 0, 1 by writing to port D 2, 0, 2. So now data already inside that memory. Okay.
Mr. Pham?
Yeah.
Basically, we are doing a negative pulse with those 3 steps, right?
Yeah, that means first thing they high,
Yes,
they go low,
yes,
then they go high.
yeah. And that is the negative pulse we need on pin 18 U8, right?
Enable.
Yes.
Okay, enable. And that is true every time that we write and read data
No,
from
right. I'm talking about right.
only for write. That is valid. The negative pulse is only needed for write data.
Right.
Okay, okay, thank you.
Now, read. For read data, then you get 2 ways to do. Okay? You can write to port B, 0x1, 2. You want memory G to be 0. Memory write to be a 1. And also enable U7. That means they included inside write to port B. Otherwise, you just call U7 enable. Inside U7 enable, you must be include memory G equal 0. Memory write have to be a 1. Okay? So the data have to be 1, 0. Either way you want to do. However, I prefer,
The data have to be 1, 2. You mean 12, not 1, 0.
yeah, 1, 2. Okay? You write port B, 1, 2. Same thing you say U7 enable. In U7 enable, we already set memory G0, memory write equal 1. Okay? And also enable pin number 18. Now you can set it to be 0. They don't need any points.
Hey, Mr. Pham, when, if you didn't comment that out, would it still pass or just wouldn't take it because it's redundant?
If you're using U7 enable,
No, I'm saying that whole thing. If you use that whole thing, it wouldn't go through.
no, don't using both.
They're the same thing.
Yeah.
They doing the same thing.
You can't use it twice in the same
Exactly.
definition.
If
So-
you want to write port B here, you don't need to call U7 enable.
But you still got to write the port D.
Right. That is a difference.
Yeah, yeah. I see what you're saying. Line, you for line 320 and 321 is either or, write one or the other, but not both.
Exactly.
Okay, yeah.
Okay, so that's read memory. Everything also including in a function. Now, when we testing, okay, you get a test number 1. Okay, test number 1, you will be there like 5. Okay, and you read it. Okay, and then you can write data AA and you read it. Okay, so that's the first 2 tests. Now, test number 3, I want to write data 55 to address AA. Then also I want to write okay, I want to write address 55 and the data AA. Then I start reading. Okay, I start reading at the location AA, data 55, and another one will be reading at location 55 and data will be AA. Okay, so you can say for the reading, you just call the function write address to memory. What address you want to read? Then you gonna read memory. Okay, then the data will be coming out.
Hey, Mr. Pham,
But writing to the memory. Okay, first thing you have to say write address AA. Okay, then you have to write a data 55 and you call a function write to memory. That complete for writing one data to one address. And the rest of the program will be the same like the old one we already did it. That means after number 4, we want you to test memory ADC data. They will be same thing, okay? Inside the other program. Just copy, paste them out.
From DLAB 9.
And also test even or test odd, same thing. So only the basically in the function definition. If
Mr.
you
Pham,
understand the function definition, that means you understand how the circuitry working.
I have a quick question, and this is the perfect spot. In regards to U2 latch, since we write to port B 0x00 for U2 latch, and we also write to port B 0x00 for U2 enable, will that cause an error in the program, or is it okay because they're not within the same definition?
Same thing. Nothing error.
Okay.
Okay, any question, anything else?
Just
Are you
one
going-
thing, Mr. Pham, it's real minor. On your, when you do your read of port C, you use the old test evaluation. You didn't use the test validate after read memory.
Yeah, normally for this line here, I combine to get the that valid
Validate.
date.
Yeah.
See, instead you typing like 241, 42, 43, and so on, then you can get the get I call a that validate. Okay. However, I like to using major data here. That when I read the program, easy for me to understand. If you say that validate, then you have to keep in mind that include major data, that evaluation, if no go or if go. They working identical.
Does validate just mean that's there, and then that information that you got highlighted is down in the function definition?
Right.
It just saves you from more typing.
Yeah.
That means you don't have to type in more.
Mhm.
However, when they reading the program, they have to find out what in that validate. If you put a coding in here, then you can understand right away.
Mhm.
Either way you want to do.
All right.
Mr. Pham, are you going to share with us that code?
Say what?
The code of DLAB 11. Just checking. I'm only checking.
Yeah, we get the hardware, we just build it. And now Mr. Pham will be verify the hardware working. Then we will take it out for you guys.
Okay.
So the thing is after this memory, next part will be DA converter. We'll be learning how binary can converting into analog photon.
Wonderful.
Marcelo, just want to see if you slip up and put the whole thing on the web.
just to want to be focused on the circuits.
The thing is you understand, in any computer system, they have to deal with the signal outside, like temperature. See that? However, when they go into the computer cannot understand how many degrees of temperature. Temperature will be analog signal. So that's why before they go into inside the computer, they must be converting from analog into the binary. That device we call an A to D converter, analog converting to digital. And after the analog signal converting into digital, computer will be analyzed and will be sending out the signal. However, the signal coming out, they will be binary. We not deal with binary. We deal with the real signal. How many degrees? 70, 80. So now they have to output of the computer will be go to device. We call it D to A converter.
That is wonderful, Mr. Pham.
They're converting binary back to analog signal and send it out.
Does that include a transducer to
Everything.
decide the temperature and turn it into a
Right.
digital
That's it.
signal? Right.
Yeah. Now I talking about very simple thing, your cell phone. When you're talking to your friend, that signal coming out will be the voice, right?
Right.
Go into the microphone. They're converting into the voltage. Okay? But that's analog signal. that voltage will be go to the A to D converter. So that device will be converting your voice into the binary. So the computer can analyze, can do it. So after the computer done, they sending out, but they sending out binary, not equivalent to your voice. Then that binary must be converted to the device D to A converter. They converting binary back to your voice. That's why they can go to the speaker, and that's why the people can listen. In any system, anywhere, they must require those two devices, AD converter and DA converter. Without those devices, computer cannot know anything.
Wonderful, wonderful. Eager to learn about that, Mr. Pham.
Yeah.
Hey,
Now,
Mr. Pham, oh, go ahead. I had just a basic question, a little bit off the subject. When we first started this stuff, you talked about digital, which is the base 10, binary, which is the base 2, and hexadecimal is the base 16. Now, octal, which is the base 8, what function or what does it play in electronics, or has it been totally eliminated, or what?
no, I'm telling you, computer understand only one thing, either 1 or 0. Okay? They understand only binary. However, the human cannot deal with the binary. 0, 1, 1, 0, 0, 1, 1. No, no way. So that's why inside the computer system, they get the design to converting hexadecimal into the binary. Hexadecimal to deal with the human. You can see number 0, 1, 2, 3, 4, 5, 6, but the computer cannot understand. So that's why they get a hexadecimal system. When you're using hex, they convert into the binary. So
But when I was asking you, Mr. Pham, we don't use the optical system in
no, the thing
electronics.
is, octal system, the same like the hex, but in the past, now they're not using octal,
Okay.
they're using the hex better.
So octal is basically obsolete.
It's like Latin. No one speaks it anymore.
Okay, now the other thing I also let you guys understand. You understand the processor, your computer now. Okay? They cannot do like your cell phone. Your cell phone, they also include ADDA converter. Okay? Now, try to understand now they're using what they call a microcontroller. That's just a one IC, one chip. So what's the difference between the processor, CPU, and the microcontroller? Who knows?
Microcontroller can control another IC.
CPU, that's just a one IC. Microcontroller also just a one IC.
But don't the microcontroller, is that the one where you have to have something burned into it?
No. What I say, what the difference?
Microcontroller is very limited in memory.
No.
Is it ROM versus RAM?
No. That's not. I'm telling you. The thing in your cell phone, they're using microcontroller. If they're using the CPU, then they have to add in too many things. AD converter, DA converter. Okay. So in order to get your cell phone, they get the, but for sure they must be get the CPU. Then they have to add it. ADDA converter, something else. So now, what they doing now, they try to put everything inside one IC. That means the different microcontroller inside, they including memory, including AD converter, DA converter. That means whatever need, then they put into one IC. If they try to doing a separately, CPU and ADDA, they make a too much room. Okay, so that's why they put everything inside one IC. They call it microcontroller.
Your cell phone would be the size of your living room couch?
Right.
So basically, Mr. Pham, you're saying that like a microcontroller can be like a really like gigantic circuit, but it's compacted in a small chip.
Right. So that's why you can see your cell phone. Small one, but they include everything.
Mr. Pham, and is there a chance that you teach us a little bit about microcontrollers to programming them?
No, you can, we don't teaching the guy about microcontroller.
How come?
Oh,
That's
why
okay.
not?
No,
How
no,
come?
no. The thing is that to be our scope of the technician. You see on the DLAB box, we're using microcontroller.
Yeah, but many of us in your class also want to be an engineer in the future.
If you want engineering, you will be learned from university.
Mr. Pham, comment?
Too expensive, too expensive.
Now, don't worry. If you think you can do it, I recommend go ahead and keep moving.
Okay.
And Mr. Pham, but we still probably need to know about microcontrollers in the sense that the control box that we use to test our circuit. So it would be nice to know that once we checked our circuit, we checked our hardware, we checked our software, and we know the problem is coming from that box. So we should know a little bit about that.
Right. When you do the lab. But that will be just outside the box.
One step at a time.
Okay.
Mr.
Baby
Pham,
steps.
The thing inside the box, we bought the microcontroller.
Hey, but on those microcontrollers, do they have to be burned?
Yeah, that's what we bought it. Then we have to burn the way we want.
So when you burn it, when you burning them, you're like burning a program into them.
Right.
Is that right?
Yeah, exactly.
Mr. Pham. Mr. Pham.
Yeah.
What I was just going to say was technically you're teaching the insides of a microcontroller from your schematics on a small scale, right? You're showing the memory, you're showing the various
Sort of dissecting.
CPU structure, the structure of a microcontroller, but it's you're showing something general of a microcontroller in your schematics of how it should work.
If you understand the memory and the ADC and the DAC, you're sort of deconstructing what's inside a microcontroller.
Exactly. And then the program, technically, all you have to do is just burn it in. But, you know, we're learning some of the basics. We're just not learning exactly a microcontroller.
Okay. If we want to burn, then you have to buy the equipment. I bought it so we can burn for the lab.
But you're the only one to know how to use that, right, Mr. Pham?
I know how to use, but the one writing the program is Mr. Tai.
Okay.
So I want Mr. Tai, if he gets a chance, he can try to let the, If I want the data coming out from that pin, how can we tell the controller? Normally he's using C++, I believe so. But I really want to learn how to write the software to control the microcontroller. Inside they get too many things. They can program D to A converter. That means you want the program any voltage they can program to you, sending out.
Do you have fresh 4550s ready to have them available for the students to purchase? Or however, you know, if we're gonna build a board, do you have any of the 4550s to replace the existing boards that have been built? Like the one that I built, I'd like to try and get a couple more 4550s for backup. So I'm just wondering if when we get back into class, are you going to have the 4550s, the new ones with the firmware on them available for purchase?
Yeah, we do.
Thank you.
Right now, I get a lot of work. I have to go to the class and try to set it up. So for 2 rooms, how many lab in each room? Therefore, then all of the students. Then I have to deal with the texture on of the box. I see how many box we get right now, and I have to run a cell test for that box. Okay, to make sure on the box will be working. And then also I can planning to let the student borrow 1 week. That means inside 1 box, including the system, including the wiring tool, the IC, ready for the guy to build. So that can save the space in the classroom. You take it in, okay? You bought it 1 week. I say 1 week you must be done. Okay? So I
To
can
what?
say, yeah,
Excuse me, I was just going to say something.
yeah,
Go ahead.
go ahead.
No, you answered the question, Mr. Finn.
That still too many things have to be done in July. The thing is, August will be too late. Also, I have to say how many students have to do the lab fold, what more I want them to be done, and how many people try to get the lab. Lowell, you've been with me for a while, right?
Yes, Mr. Finn.
Okay, I think you better concentrate on the one in the digital. The thing is, everything now controlled by digital. Like, learn
Yeah,
how to program, how to burn the controller. Mr. Tai, take me, I take you.
my main thing that I've been trying to just keep refreshed and understand more is the Tech 1 basics, all the basic circuits. I need to understand those first, how they work, and then after, you know, I get a pretty good stronghold of a lot of the Tech 1 basics. Then I shouldn't really have an issue about programming. At least not for just this class, but just in future aspects. Because the software, I have a lot of the coding for the software from what you have what you've taught, but I believe understanding how the circuits work first is most important, just so that the coding can be reasonably typed out and understood and interpreted. I can interpret the schematics. That's not all too difficult. You just have to sit and work with it.
In some ways, Tech 1 is a lot more difficult than Tech 2 is. There's a lot more math involved and equations to remember and everything.
I have knowledge. I've been with Mr. Frown for a little while, but that's why I'm still here in the class, is I'm keeping my mind stimulated. So yeah, I'm looking forward to actually getting back into class when the opportunity becomes available. Thank you.
Okay.
Thank you.
So that is it. Any question?
All right, Mr. Pham, thank you for all your knowledge
Yeah.
and help.
Thank you very much, Mr. Pham. It was a good class.
Okay. Good night, everyone.
Good night.
No.